The Vault at National Museum of Military Vehicles has a wide variety of anti-tank weapons. There was the LAW. Then there was the AT-4. But between the two, there was an overly expensive and failed false hope. The Viper. FGR-17, or Viper, began development in 1976 by General Dynamics, with the intention of replacing the M72 LAW. However, there were a few things in its way. It was dangerous to the user. The Viper was so potentially dangerous that Congress had to step in, which eventually stopped the program. And the cost. It just kept increasing while never delivering on the Army's wants. The FGR-17 Viper. It fought the law, and the law won. By 1972, the Army's brain trust was looking for something to replace the M72 LAW, something with more punch. U.S. Army doctrine of the era emphasized man-portable, disposable anti-armor weapon systems, allowing light infantry units fire-and-forget simplicity. In 1975, a program designated ILAW, Improvised Light Anti-Tank Weapon, issued a request for proposals. General Dynamics secured the development contract in 1976. When the Army designated General Dynamics as the prime contractor, the program changed its name from ILAW to Viper and was assigned the designation XFGR-17 Alpha. The main requirements for the Viper program were to develop a one-man operated, disposable, shoulder-fired weapon of the same weight and size category as the M72 LAW, with intended improvements in accuracy, safety, and penetration. Also, the Viper was not to have a significant increase in cost per round over the M72 LAW. According to General Dynamics' production brochure, they specifically stated that the FGR-17 was best deployed in close quarters against enemy flanks and rears, already having sacked the Army's original hope for the weapon's ability against frontal armor. Development progressed at facilities including Fort Benning and Redstone Arsenal. The system's ergonomics were improved. A weighted section was added at the rear to address backblast dynamics and prevent the tube from tumbling uncontrollably after rocket launch. In 1981, the design received production approval, though there were concerns. Looking at the Viper, you can see it resembles the M72 LAW, notably the fiberglass telescopic tube. It weighed approximately 8.2 pounds. Length was just under 44 inches when extended for firing. Effective range was 250 meters for moving targets, 500 meters for stationary targets. Muzzle velocity was 257 meters per second. Unlike the M72 LAW, the Viper's tube extends forward of the firing mechanism rather than rearward. It uses flip-up aperture sights. Extending the launcher's tube automatically releases and flips up the sights for use. To fire the weapon, you first remove the rear cover. The front cover is typically pushed out by the missile upon firing. Then extend the tube. Pull the telescoping tube forward until it locks into place, which, as I mentioned, also sets up the sights. Use the aperture sights to track the target. Fire the weapon at the Warsaw-packed target, hit said target, and discard. Once the 70mm unguided heat rocket is launched, the tube cannot be reloaded and must be discarded. The missile has a solid rocket-powered booster and a heat warhead. 9 collapsible fins extend in mid-flight to ensure a stable flight path. The missile fires via an impact fuse. The FGR-17, like all weapons of its kind, produced a backblast. When the ILAW requirement was first issued, the Army wanted an individual anti-tank weapon with such a low cost that it would be as common in infantry units as hand grenades. The Vipers were initially projected to cost about $75 apiece, but design changes began almost as soon as the weapon was produced. The weight, it was decided, must be reduced to less than 7 pounds. This meant the warhead weight was reduced. which sharply limited its potential destructive power. The size of the rocket motor was also reduced to cut blast noise. After redesigning it, the Viper's initial production cost was not $75, but $787 apiece. And what did the Army get for their almost 900% increase? They received a problem child. Fuse system malfunctions, premature detonation. Test firings revealed a safety issue with the fuse, causing the warhead to explode shortly after launch rather than on impact or at the intended time. The Army noted that that was a significant reliability and safety concern. Good catch, guys. Next issue, static electricity sensitivity. Viper rounds showed vulnerability to static electricity, which could damage or prematurely trigger them. One documented incident at Fort Benning, Georgia, involved a helicopter pallet of Viper rounds being damaged by static discharge. This raised serious handling and transport safety risks in field conditions. Also, reliability problems. The propulsion system and trigger mechanism had an average technical reliability coefficient of about 0.947. During tests, that was not a desired standard. Piezoelectric fuse performance was unsatisfactory. There were issues with the shaped charge warhead, including incomplete detonation or failure to function properly. Overall, roughly 15% of the rounds fired in tests did not work as intended for a number of reasons. Later fixes, like lowering the fuse activation threshold, strengthening the structure, and enhanced launch tube sealing, improved results in retests, but the concerns persisted. While some tests showed the Viper was marginally more effective than the M72 LAW in penetration and range, it did not deliver the major improvements in accuracy, lethality, or overall capability that were anticipated. Sights were simpler, and one could say less effective than those on the LAW. It simply failed to convincingly outperform existing or competing systems, enough to justify its development. And of course, we have to talk about the cost overruns. The weapon became far more expensive to produce than originally projected, contributing to congressional scrutiny and eventually cancellation. Costs had ballooned far beyond original projections. At one point, the Viper price grew to just under $1,800 apiece. That is a 2,300% increase from the original proposed cost. The Army scrambled to justify the weapon's development. Their bureaucratic solution? If the weapon will not do what it's supposed to do, redefine the mission. The Army decided the Viper could be used to snipe at tanks from the side or the rear, however limiting that would be to the soldier in the field. In February 1982, the Army surprised everyone by awarding General Dynamics a second production contract worth $83.7 million for 60,000 additional units. This decision, coming amid known problems, triggered a strong backlash. Congress requested or prompted a classified U.S. Government Accountability Office, or GAO, investigation into the Viper program. The resulting report was highly critical. It stated that the Viper barely met the low end of the Army's requirement. It concluded that the Viper did not demonstrate any significant superiority over the M72 LAW. The report highlighted performance shortfalls, reliability problems from testing, and, matter-of-factly, given the issues, the lack of justification for continued large-scale procurement. The GAO findings were highly publicized and became the focus of congressional hearings and inquiries. Lawmakers were particularly angered by the second production contract being signed despite all of the red flags. By December of 1982, Senator Warren Rudman inserted an amendment into the Army's fiscal year funding bill that cut 69% of the remaining Viper funding, mandated a competitive evaluation of off-the-shelf light anti-tank weapons already in production, and required the Army to report back to Congress on those results. The congressional pressure, combined with the negative GAO assessment and ongoing test failures, led to the program's termination in October of 1983. General Dynamics declined to participate in the mandated competition under the fixed-price terms that would have required them to fix the safety and reliability issues at their own expense. When the Viper program came to an end, the Army had spent, in current dollars, over $830 million in a failed attempt to replace the law. The Army was forced to consider alternatives, and after the competitive testing ordered by Congress, ultimately adopted the Swedish-designed AT-4. The Marine Corps, who had also intended to purchase the Viper, instead adopted the Mark 153 SMA. Well, there it is, the story of the FGR-17 Viper. And although this story on its surface may seem like one of grift, one of shenanigans by the Army as well as by General Dynamics, it's actually a little more hopeful than that. You have to understand that we were coming out of the 70s where overexpenditure and cost was prolific. By the early 1980s, though, Congress is reining that in, and this is a good example of that. What we get at the end of this fiasco is actually a better weapon system with the AT-4, one that, in my experience and use in the military, was the right decision. The AT-4, the SMA, were both better weapon systems than even the hoped-for potential of the FGR-17 Viper. If you don't agree with me, go ahead and leave a comment below. Love to hear from you.